for the voltage drop for a feeder loading? Is it the expression what we are deriving? Okay, so already in the last class, okay, so a transmission line with a resistance and an inductance with a loading of P plus JQ and Vs and Vr. Okay, so we have written the expression Vs is equal to Vr bar plus IL into R plus J into X. From this, we wrote the expression VR bar plus, what is the expression for us? IL, what you are writing? P plus JQR, P plus JQR by VR, is it the expression or not? Into R plus JX. Okay, so from that, Vs bar is equal to VR bar plus P in PR into P into R, or PR plus X into QR by VR. Is it the expression what we have derived? Is it the expression what we have derived in the last class? Please respond, ma. Did we complete it up to here?
Yes, ma'am.
Yeah. So from this, can I write Vs bar minus VR bar is equal to PR into R plus X into QR by VR? Can we? Okay. So can we? Okay. Per unit base value, per unit voltage drop, per unit voltage drop is equal to Vs bar minus VR bar divided by VB is equal to PR into R plus X into QR, X into QR by VR into VB. Can I write like this? What is the per unit value? How will you get the per unit values for any of the expression? How will you get the expression? Are you there in the class, ma? Please respond.
Yes,
How will
ma'am.
you find the per unit values? The expression divided by the base value or not?
Yes, ma'am.
Yeah. So here the base value is taken as VB. Here the base value is taken as VB. So then the expression can I write like this: Vs bar minus VR bar by VB is equal to PR into R plus X into QR by VR into VB. Is it okay?
Yes, ma'am.
Yeah. So here VB is the system voltage. VB is called as an system voltage or base voltage or base voltage. Is it not? Okay. What is PR? What is PR? What it represents? What is PR? Is it the active power or not? PR is equal to, is it the active power? Is it the active power or not?
Yes, ma'am.
So what is the value of active power? V into I into cos theta. Can I write like this? And QR is the reactive power. QR is the reactive power, which is equal to V into I into sin theta. And S is the apparent power. S is the apparent power, which is equal to V into I. Can I? So I'm replacing PR as S into cos theta. Is there any wrong if I write like this? And QR is equal to S into sin theta. Is there any wrong if I write like this? Can I? Can I write like this? Okay, so on substituting this value of PR and QR, what will be the expression? S cos theta by VR into R plus S sin theta into X by VR by VB. Can I write like this? Is there any wrong? Is there any wrong? Is there any wrong?
No, ma'am.
Yeah. So from this, what can I write? Okay. What can I say? S is the common term. So R cos theta plus X sin theta by VR into VB, VR into VB. So which is expressed, if you observe, the voltage drop is now expressed in terms of apparent power. Is it not? In the last class, we have shown that the voltage drop VR minus VS is equal to I into R cos theta plus X into sin theta. Did we have this expression? Did we have this expression? Did we have this expression, ma?
Yes, ma'am.
Yeah. So here, what is the difference between these two expressions? Here, both are the expressions for the voltage drop. Is it not? Both are the expressions for the voltage drop. Is it not? Here, the voltage drop is expressed in terms of current, whereas here the voltage drop is expressed in terms of current. Whereas here, the voltage drop is expressed in terms of power. The voltage drop is expressed in terms of power. Is it clear? Is it clear? Did all of you understood this point? Is it clear? Did all of you
Yes,
understood
ma'am.
how I wrote the expression? Okay, please all of you copy up to here. Please all of you copy up to here. Did all of you understood the thing or not? Just I am replacing the value of PR and QR as S cos theta and S sin theta, where S indicates the apparent power, and also we can also say that it indicates the rating of the system. It indicates the rating of the system. Is it not? Did all of you completed, ma? Did all of you completed?
No, ma'am. 1 minute.
Okay.
Yes, ma'am.
Yeah. So here now, it is a single phase system. If suppose if it is a three-phase system, can I write PR is equal to S3 by 3 cos theta for a three-phase system? The suffix 3 indicates that it says that it is a three-phase system. It indicates that it's a three-phase system. And similarly, QR is equal to S3 by 3 sin theta. Is it not? Okay, it's for a three-phase system. And similarly, can I write capital R is equal to small r into L? Okay, small r into L. Can I? Okay, capital R is the total resistance offered by the system. Okay, whereas it is given as the resistance of the transmission system into the total length of the line. And similarly, Q is equal to, or sorry, X is equal to capital X is equal to small x into L. Is it not? So on substituting these values, how can I write the expression? S3 by 3, okay, into R into L into cos theta plus X into L into sin theta by VR into VB, by VR into VB. Did you got my point? Did all of you understood this thing?
Yes,
Is
ma'am.
it clear? Yeah. So from this, okay, can I write S3 into L by 3 into VR into VB into R cos theta plus X sin theta, X sin theta. Okay, is it clear? Is it clear? So, whereas S3 is expressed in terms of kilovolt, so I am representing as 1000 volt ampere. Can I write like this? Is there any wrong if I write like this? Is there any wrong? What is S? What is S? What is the unit for 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 S? Ma, are you there in the class or not? For whom we are saying the classes? What is the problem for responding? What is the unit for the apparent power? Is my voice audible to you or not? Are you there in the class? So here, okay, I am writing this expression as voltage drop is equal to L into K1 into S3 in simple. I am writing the voltage drop is equal to L into K1 into S3. What is the value of this K1? What is the value of this K1? So voltage drop is equal to, what I am writing? Voltage drop is equal to L into K1 into S3. So what is the value of K1? Can I write it as K1 is equal to K1, your LS, other than LS, all I am considering it as K1. So K1 is equal to, what is the value? R cos theta plus X sin theta by 3 into VR into VB. Is it not the value? Is it the value? Is it the value?
Yes, ma'am.
So this is the expression. What about value of 10 cube? What about the value of 10 cube? If I consider this as into 10 to the power of minus 3, then what happens? What happens? 10 power minus 3 and 10 power plus 3 get cancelled, and the resultant is L is equal to, if you consider it as K, okay, L into K into S3. So K1 is equal to, what can I write the value as K1? Here in this expression we are having 10 power cube, is it not? Are you following?
Yes, ma'am.
What is the what I am doing here? How I am eliminating this 10 cube? Here in the factor I am multiplying with a value of 10 power minus 3.
Mine.
Yeah. So can I write K is equal to K1 into 10 to the power of minus 3?
Yes, ma'am.
Okay. So by that, what will be the value? What will the value? The resultant voltage drop in simple. What I am saying is, what I am saying is, the voltage drop is equal to L into K into S3. The thing what you have to remember is this one, okay? Because it is useful to us in the next case. So voltage drop is equal to L into K into S3. Is it clear? L into K into S3. S indicates here. S indicates here. S indicates here. S indicates here. What's the S value? What is the S value? S is the apparent power and K is the constant or given as R cos theta plus X sin theta by 3 into VR into VB, and L is the length of the transmission line, and L is the length of the transmission line. The expression what you have to remember is this. Here the thing what is you have to observe is this value of L, this value of L, okay, varies with respect to the loading. The value of this L varies with respect to the loading. How many types of loadings are there? How many types of loadings are there? Okay, so all of you copy up to here. All of you copy up to here. All of you completed, ma'am? All of you completed?
1 minute, ma'am.
Yes, ma'am.
Okay. So here the different types of loadings. Okay, did you heard about the uniformly, the feeder loading uniformly? Did we learned in PS1 or not? Feeder loading uniformly. What is the meaning of this? How the loading is? Okay, if it is a line, okay, I, 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 I. What is the meaning? If the arrangement is like this, what you say? What you say? The feeder
Load is
is loaded.
distributed
Yeah,
equally.
the load is distributed uniformly. Okay. Then what is the expression for the voltage drop we have derived? Voltage drop is equal to what we have derived? L into K1 into PS3. This is the expression. Okay, the value of this L for feeder loaded uniformly is given as L is equal to L by 2. L is equal to L by 2. Is it clear? Okay, here we are not deriving the expression. Already you have derived these expressions. What is the expression for the length for uniformly feeder loading and increasing load and so on. So here just I'm recalling the value. Okay, so for you, if the feeder is loaded uniformly, then L is equal to L by 2. And the next one, if the feeder is loaded at 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 only one end, if the feeder is loaded at only one end, then what is the value of L? It is equal to L is equal to total length. L. L is equal to total length L. If the feeder is uniformly okay loaded uniformly, that means either increasing or decreasing loads, then the value of L is equal to 2L by 3 or L by 3. 2L by 3 is for increasing load and L by 3 is for the decreasing load. Did you are recalling these values or not? Did you remember?
Yes, ma'am.
Yeah. So here the thing what you have to remember is when the feeder is loaded uniformly, what is the value of L? What is the value of L? L is equal to L by 2. If the feeder is loaded only at one end, that means the load is connected at the one end only, then L is equal to L. Okay. And if the load is increasing, that means if it is I, the next one 2I, next one 3I, the next one 4I, in this fashion, then the length L is equal to 2L by 3. If it is of decreasing, that means 4I, 3I, 2I, and so on, then L is equal to L by 3. Then L is equal to L by 3. Did all of you understood? That all of you have to remember these things. Is it clear? What is the expression for L for uniform loading? What is the expression for L for uniform loading? L is equal to uniform loading. L is equal to uniformly. If the feeder is loaded uniformly, what is the value? L is equal to. Please respond, ma. What is the problem for you all? So all of you note down. All of you note down. If the feeder is loaded uniformly, then L is equal to L by 2. Then L is equal to L by 2. Next point. If the feeder is loaded at only one end, then L is equal to L. If the feeder is uniformly loaded with increasing load, L is equal to 2L by 3. L is equal to 2L by 3. Next line. If the feeder is uniuniformly loaded with a decreasing load, then L is equal to L by 3. Then L is equal to L by 3. Then L is equal to L by 3. Is it clear? Is it clear,
Yes,
ma?
ma'am.
Yeah, okay. So, did all of you completed up to here? So, what is the expression for the voltage drop, ma? What is the expression for the voltage drop expressed in per unit value? Expression for voltage drop expressed in terms of per unit value. What is the expression? What is the simplified form? What is the simplified form? What we have derived? What is the expression? Is it the expression or not? Voltage drop is equal to L into K into S3. Are you following or not?
Yes, ma'am.
What is K? What is K? R cos theta plus X sin theta by 3 into VR into VB. R cos theta plus X sin theta by 3 into VR into VB. Okay. And what is S3? What is S3? Apparent power.
Apparent.
S3 is the apparent power. Okay. Did all of you understood? Okay, can we move to the next one? Is it clear,
Yes,
ma?
ma'am.
Yeah. So the next one is, okay, the next one is square shaped distributed service area. The next one is square shaped distributed service area. Okay, square shaped arrangement. Please, all of you copy this diagram. Okay, all of you copy this diagram. All of you copy this diagram. Square shaped arrangement or square shaped distributed service area. Square shaped distributed service area. All of you have the heading square shaped distributed service area.
Okay, ma'am.
Okay. So did all of you completed? The remaining members also?
Yes, ma'am.
Yeah, fine. So what can you understood from the diagram? Anyone? What you are following? What you can understand from the diagram? Anyone? Can you explain? Can you explain what you can understood from the diagram? How the arrangement is and what is representing? Anyone? So already we have discussed. Already we have discussed. The better one is okay. Substation connected in circular fashion of the feeders, but in all the cases it's not possible. So here if you observe this arrangement, here the center one is representing the substation. Okay, the center one is representing the substation, where the substation is okay connected or is divided with an four feeder lines, where they are connected in a fashion of square. Is it not? This is a feeder 1, 2, 3, 4. How many feeders are there? 4 feeders. The total substation is connected to 4 feeders. Out of these 4 feeders, here we are showing a 1 feeder arrangement. Okay, so this is the load center. And this is the feeder load center. Okay, at this point, we are observing the distribution transformers and the laterals. From this feeder load center, again these are connected to the transformers, and the transformers are provided with an laterals. So can I say the rating of the total substation is the rating of the individual feeder The rating of the total substation is equal to the rating of the individual feeder. Is it not? The rating of the individual feeder means the rating of the feeder 1 plus rating of the feeder 2 plus rating of feeder 3 plus rating of feeder 4 gives you the total rating of the substation. Is it not? Is it not? So how
Yes,
will you
ma'am.
calculate? How will you calculate the feeder rating? The feeder rating is equal to the load connected to that feeder. The total rating of the feeder is nothing but decided by the load connected to that feeder. And how the rating of that load is calculated based on the number of loads connected to the feeder. That is nothing but the number of laterals connected to that feeders. The laterals rating, the total sum of the lateral ratings gives you the feeder loading, and the feeder loading gives you the sum of the feeders gives you the rating of the substation. Is it the sequence or not? Is it the sequence how we have to calculate the rating of the substation? Because directly we
Yes, ma'am.
don't calculate the rating of the total substation. So the rating of the sum of the ratings of the laterals gives you the rating of the feeder, and the ratings of the feeders gives you the sum of the ratings of the feeders gives you the rating of the substation. Rating of the substation. Is it clear? Is it clear? Did all of you understood? So here, what is the arrangement? Here, what is the arrangement? How you observe how the arrangement is? Is it in the square? Is it in the square fashion or not? Is it in the square fashion or not? Okay, is it in the square fashion or not? Arranged
Yes, ma'am.
in a square form. Arranged in a square form. So it is named as a square-shaped service area. Square-shaped service area. So all of you write down. All of you write down. All of you write down. Let L to the suffix 4. Let L to the suffix 4 is the L to the suffix 4 is the length of the feeder. L to the suffix 4 is the length of the feeder, and capital D and capital T is the load density. Capital D is the load density. Capital D is the load density, and the units for the load density is kVA per unit area. kVA per unit area. kVA per unit area. S is the capital S is the rating of the feeder. Is the S is the S4 and 9 left. S4 is the S to the suffix 4 is the rating of the feeder. S to the suffix 4 is the rating of the feeder. And so here, if you observe what I am writing, L4, it is nothing but that indicates the 4 indicates that they are representing the numbers of the feeders. How many feeders are there in this square fashion? How many feeders are there in this square fashion? Is it 4 in number or not? Okay, so the length of the each feeder is given as L4. Is given as L4, and the apparent power of the square-shaped fashion feeder is given as S4. Is it clear? Is it the suffix? In that S3 ransom. What is the meaning of S3? What it's saying that it's a 3-phase system. In the same way here, how many feeders are there? 4 feeders. So we are using the suffix 4. Is it clear? Is it clear? Okay. So write down. Next line. Area of the square. Area of the square. We are very familiar with the area of the square. What is the area of the square? What is the area of the square? Here, is this part forming a square or not? Is it part forming a square or not? If you observe this area, the center to this center, is it forming an? Here, this is the part what you are considering. Is it forming a square or not?
Yes, ma'am.
What is the length of this part? L4, and the length of here is L4. So the area of the square is equal to L4
L4
square.
and L4.
L4 square. Okay, is it not? Because here I am considering only a part of the portion of the total system. Okay, because the total system is divided into 4 squares. Is it divided into 4 squares? Is it not? Out of these 4 squares, I am considering only 1 square section. Okay, the total area of the total rating of the system is equal to 4 into this value. Is it not? Because all the 4 feeders are uniformly maintained. All the 4 feeders are uniformly distributed. Is it not? Is it clear? So here I am considering only the one section. Here I am considering only the one section. So write down area of the square is equal to L4 square. Area of the square is equal to L4 square. Okay, and what is the voltage drop? Voltage drop per unit value, what we have derived? What is the expression? What is the expression we have derived? L into K into, yes, is it the expression what we have derived? Okay, so my question is whether the rating of the distribution system depends upon this voltage drop. Depends upon this voltage drop. Whether the rating of the distribution system depends upon this voltage drop, undoubtedly. Okay, because the voltage drop also involved. And the value is to be considered while deciding the rating of the distribution system. We have to overcome this voltage drop and we have to transmit. So here the voltage drop per unit value we have derived is L into K into S. L into K into S. So what is the expression for S? What is the expression for S? What we are saying, S is the rating of the system. S is the rating of the system. Is it not? S is the rating of the system. Is it not? So can I write this as area into load density? Can I write? The rating of the system is equal to area covered by the load density of that area. Please respond. Can I write like this? Is there any wrong if I write like this? Yeah. So what is the area value? Can I write it as L4 square? L4 square. Okay.
Yes, ma'am.
And what is the load density? It is D into kVA. It is D into kVA per unit area. Into and what are the units? L4 square. Is it area? Okay, square mm square or square meter square, and this cancelled. And what is the value? S is equal to L4 square into D kVA. Is it the value for S? Is it the value for S? Is it the value for S?
Yes, ma'am.
Yeah. So here, percentage voltage drop is equal to percentage voltage drop per unit is equal to L into K into S4. S4. What is S4? S4, the apparent power of the feeder. What type of feeder? If the feeder arrangement is in square shape. So L into K into S4, L into K into L4 square into D. Can I write like this? Can I write like this? Is there any wrong?
No.
Yeah. So next, over here, is this value
No.
is this value of L depends upon, is this value of L depends upon loading type? Loading type, is this value of L depends upon the loading type? Are you following? Is this value of L depends upon the loading type or not? Already we have discussed at this point. The value of L is equal to L by 2 when the load is uniformly distributed, and this value of L is equal to L by 3 if it is increasing load, is equal to 2L by 3 if it is a decreasing load. Did we discuss at this point or not? Did we discuss at this point or not?
Discussing, ma'am.
Okay. Please, all of you copy up to here. All of you copy up to here. So did you write the expression? Percentage voltage drop is equal to percentage voltage drop per unit is equal to L into K into S. L into K into S. Where S is equal to area into load density. Where S is equal to area into load density. Area into load density. That implies area of S square is equal to L4 square. Area of S square is equal to L4 square, and load density is equal to D, and the load density is equal to D. By that, S4 is equal to L4 square into D kVA. S4 is equal to L4 square into D kVA. S4 is equal to L4 square into D kVA. Next line. Let us consider uniformly. Let us consider ununiformly load, uniformly distributed load in increasing fashion. Then L is equal to 2 by 3 L, whereas L is represented here as L4. So percentage voltage drop per unit is equal to 2 by 3 into L4 into K into L4 square into D. That implies 2 by 3 into K into D into L4 cube. So please calculate the value of 2 by 3. What is the value of 2 by 3? What is the value of 2 by 3? What is the value of 2 by 3? 0.
661.
Yeah, 0.667 K into D into L4 cube. This is the expression for the voltage drop. When? How can you express this? When the feeder arrangement is in squared fashion and the loading is in increasing fashion and uniformly distributed in increasing manner. Is it clear? Did you understood?
Yes, ma'am.
Yeah, for suppose if the load is uniformly distributed, then L is equal to L by 2, then L is equal to L4 by 2. Then what is the value? Percentage voltage drop is equal to, what you substitute? L by 4 by 2, L4 by 2 into K into L4 square into D. That is 0.5 into K into D into L4 cube. This is the voltage drop. This is the case when the loading is uniformly distributed. Then the loading is uniformly distributed. Is it clear? Ma? So for suppose if uniformly distributed with increasing load, with decreasing load, then what is the value? L is equal to L by 3. Then what is the value? Percentage voltage drop is equal to what? 1 by 3. What is the value of 1 by 3?
33, ma'am.
Yeah, 0.33 into K into D into L4 cube. Is it clear? So in this way you can calculate the voltage drops for any type of loadings, feeder loadings. Is it clear? Did all of you understood? Ma?
Yes, ma'am.
So please all of you copy up to here. Please make it fast. Okay. All of you completed, ma? All of you completed.
No, ma'am.
Please make it fast, ma. You completed, ma?
Yes, ma'am.
Okay. So we'll continue in the next class. Okay.